Hi there. I promised to build the user interface that's actually going to be calling the network APIs for this catalyst. So to set up the network slicing dynamically when someone decides to fly a drone mission. So I'm building this based on the open source as a Linux Foundation drone code project, which includes a mission planner called Q Ground Control, which is what I've got running on this laptop. And Q Ground Control lets you programming missions and then execute those missions and observe what's happening while those missions are flying. And you can see at the moment I've got the Q Ground Control and it's actually connected to this, which is a commercial drone, which is actually using the same open source standards as this Linux Foundation project. I'm not sure if you can see in the corner, you can see that as I'm moving the drone, as I'm moving the drone, you can see that the telemetry data coming from the drone is changing what's coming through on my Q Ground Control piece of software. So this is what we're going to be using, and in this Q Ground Control, what we're going to do is we're going to plan the mission, and then as a part of the checklist for starting a mission, that is where you're going to call these network APIs, and it's going to basically say to the network, what is the coverage at the moment, and actually can I order these low latency and high bandwidth network slices to enable the safe operation of a drone. So what I've done for our demonstration is I've got the same software, this Q Ground Control open source software. I've got the source code and I've built it from the source, and that's enabled me to actually make some changes so that we can call the network APIs as part of the pre-flight checks. And what I've also done is I've linked it to a simulated drone which is going to fly in the Newbury Vodafone HQ. And so I've got here it is, it's connected to that simulated drone, and in this software there's a planning stage. As you see, I've planned a mission where I'm taking off. It's taken off to 5 meters in altitude. It's going through a series of waypoints, and this is typically what you would do. And there's more complicated missions you can fly, like you can actually scan areas, and it'll build automated flight plans for scanning and for doing photogrammetry and things like that. But in this mission, we've got a very simple going through a few different waypoints and then landing. So this is the mission planner, and then what you do is you go into the flight mode, and in the flight mode, the first thing you do is this pre-flight checks, and so it knows what the mission is, so it knows the area it's going to fly. So as part of the pre-flight checks, this is where we're going to introduce calling network APIs to check against that mission, to check for things like network coverage, to actually order the dynamic 5G slice and to confirm the network status. So I've put placeholders. When we've got placeholders, it's not actually calling the APIs, but this is where we will call the APIs. And because I am building it from source, we can introduce whatever API calls we want. And this is where you also do things like you check no-fly zone. So against that mission, you check against no-fly zone databases. You can check it against the weather forecast. You can do like hardware and battery checks. It's doing checks against the sensors and against the number of GPS satellites, and these are at the moment are already automated. And this last one I'm going to remove. So at the moment it does a check that the radio interface is working, and we're going to replace that with our network check. So this is where we're going to introduce the actual custom code for our project. But just then to demonstrate it, so we've passed the checks, and it's saying if I slide this, it'll actually execute the mission.
Flight mode armed.
And if I go into the simulator, so this is actually showing the simulator. You can see I've simulated the Vodafone campus as the drone is flying down, following that mission plan. So this is showing the 3D view from the simulator. But what you see actually is the pilot is this view in this Q Ground Control application. So it's flying down, it's following the different way paths. You can track the telemetry. I could at this point, at any point, take over control of the drone, or get it to land, or even get it to automatically return to the base. So the notion is you're not actually actively flying the drone. This is typically how most sort of commercial drone flights are done. They're done by pre-planning everything, loading it into the drone, and then following a mission with the drone pilot then just really observing what's going on and able to interject. So the drone's now coming back and it's going to go into its landing sequence. You can see the drone landing back on the bridge where it took off. And that's the end of the flight. So that's what I was planning to do for the demonstration. I'm hoping to have slightly better graphics for the simulator, and we might even decide to run this in Copenhagen. So I'm interested in views if there's anywhere specifically we should set out to actually run the demo. But for now I've just done it in the Vodafone campus.